curves of molecular velocities, which comes under class 11 states of matter. Here the graphical representation between fraction of molecules with different speed at a particular temperature. When you observe the Maxwell Boltzmann distribution graph, this graph explains the different types of molecular velocities, speed versus fraction of the molecule, number of the molecule versus speed. At a given temperature, same fraction of molecules may possess different velocities. Same fraction of molecules may possess different velocities. See here, this is the fraction. This fraction of molecules, when you observe at this particular fraction, this is about the fraction. Number of molecules, how many number of molecules are there here? This is the fraction. So at this particular fraction, different velocities. This molecule is having this velocity, this molecule is having this velocity, these molecules are having these velocities, velocities. At same fraction, these all molecules will possess different velocity. This molecule is having less velocity. Velocity is from left to right increasing. So different molecules having different velocities. At a given temperature, the same fraction of molecules may possess different velocities. So they are having different velocities. When you observe the given temperature, means this is the T1, cold gas. When you indicate this T2, room temperature, and hot gas, this is T3. So when you observe this cold gas, these inside the molecules will have different velocities. When you observe another gas also different velocity. Whatever the temperature, when you observe at particular temperature, the molecules will have different velocities. Some of the molecules are having less velocity. Some of the molecules are having high speed. Second point, fraction the graph. From this graph, for a gas at any temperature, the order of velocity is in this. Cp is less than C bar is less than C. The order of the molecular velocities. Here we have three different molecular velocities. Cp means most probable velocity, C bar means average velocity, C means RMS velocity. These three types of molecular velocities is the following order. The least speed molecules is Cp. So see here students, in this graph, what is Cp? The most probable velocity means maximum molecules velocity only known as most probable velocity. Maximum molecules, see here 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. So many molecules are possessing speed, maximum number of molecules speed only termed as what? Cp, most probable velocity. So these molecules velocity is known as most probable velocity. Next, followed by this green color, I am showing you this velocity is average velocity, that is represented with C bar, and remaining velocity is RMS velocity, or we can represent it with C. It means gaseous molecules will have three different velocities: most probable velocity, average velocity, and RMS velocity. These velocities is in the following order: speeds. A velocity of the molecule increases, the fraction of the molecule possessing a particular velocity also increases up to the maximum value and then decreases. See here students, third point, when velocity increases, when you see in the x-axis, the speed is left to right increasing. Left to right, the speed is increasing here. So here this is a fraction. At this particular fraction, this is the speed. At this particular fraction, this is the speed. At this particular fraction, like that, when fraction increases from bottom to top, number of molecules are increasing. Bottom to top, number of molecules are increasing up to maximum value here. And again, number of molecules are decreasing. Number of molecules are decreasing. So that finally when you see here, very few number of molecules are there. It means when you see at this particular fraction, this is the velocity. At this particular fraction, this is the velocity. At this particular fraction, this is the velocity. Like this, the fraction increases, velocity is increasing. Fraction means number of molecules. So here only one molecule is there. Here number of molecules 1, 2, 3, 4, 5 are there. The number of molecules increasing, the fraction increasing, velocity increasing. Up to where? Up to this maximum value only. Afterwards, it is coming down. Fraction is decreasing. Finally, at this particular fraction, here the velocity is high, but fraction, when you see here, a very few molecules are there. A very few molecules are there. That is the reason, as velocity of the molecule increases, what is increasing? The fraction of the molecules increases up to maximum value and then decreases. Fourth point. As the temperature increases, the fraction of the molecules decreases. Temperature increases, fraction of the molecules decreases. See here, temperature, this is the T1 temperature, this is T2 temperature, and this is T3 temperature. Temperature increasing. T1 is less temperature, cold, room temperature, and hot. When temperature increases, what I am giving the point here, the fraction of the molecule, number of molecules are decreases. Temperature increases, molecules are decreasing. See here, students. So this is the T1 temperature, this is the curve. At this curve, for example, I am observing this fraction. This is the fraction. How many molecules are there, for example, this fraction? So 1, 2, 3, 4 molecules are there. 1, 2, 3, 4 molecules. When temperature increases, this is the increased temperature curve. When temperature increases, this is the increased temperature curve, T3 temperature. What happened here? How many molecules are there? 1, 2, 3, 4 molecules are there. When temperature increases, so only one molecule is coming here. It means fraction is decreasing. Temperature, at less temperature, 4 molecules are there. At high temperature, only one molecule is coming. It means fraction of the molecule decreases. As the temperature increases, the fraction of the molecules decreases. One more point. And the temperature increases, the fraction of the molecules possessing high velocities increases. Temperature increases, fraction decreases. Again, temperature increases, fraction also increases. Here decreases, some molecules fraction decreases, some molecule fraction increases. See here. Here temperature, this is the increased temperature. When temperature increases, when you take this fraction, what I told, molecules are decreasing. When you observe here, for example, this is a cold gas. This is the cold gas curve. Here starting point, here ending point. Now, these molecules are possessing high velocities, which is there in the cold gas. When temperature increases, the curve, this curve becoming like this curve, increased temperature. Increased temperature, the number of molecules fraction is high. See here. Here 1, 2, 3, 4 only there. When temperature increases, high velocity molecules fraction also increases. Number of molecules increases. Temperature increases, some of the molecule fraction decreases. Low velocity molecules number decreases. Temperature increases, high velocity molecules number increases. Low velocity molecules number decreases, high velocity molecules number increases. That indicates the fourth point. Fifth point, as temperature increases, height of curve decreases and flatten and becomes broader. See here, temperature increase temperature, it is width is increasing, it is coming like this. Sixth point, area covered under the different curves is same as it represents the total number of molecules present in the gas. Area covered under the different curves is same. Whatever the curves, 3 curves you are seeing, that is for only one gas. Whatever the molecules are there in the cold gas, the same number of molecules are present in room temperature also, T2 also. this is T2, and this is T1 temperature, and this is T3 temperature. In all the cases, number of molecules will be same. Number of molecules will be same. A area covered under the different curves is same as represents the total number of molecules present in the gas. Whatever the molecule present in this gas, same molecule present under this curve, same molecule is present under this curve. Just we have increased the temperature from here to here, here to here. The graph is moving like this. Moving like this. Seventh point, at any temperature, the order of number of molecules is like this. Cp, more number of molecules are there. It means most probable velocity molecules number is high. Next, average velocity molecules number of molecules is less, and RMS velocity number of molecules are very few. See here the graph. Here most probable molecules N is high. Velocity and molecules number count also high while comparing with average velocity, while comparing with RMS velocity. RMS velocity molecules number is less, most probable molecules number is high. That is indicating seventh point. See here, at any temperature, order and number of molecules is like this. Ratio between molecular velocities. When you observe the ratio is in the following order. Cp is to C bar is to C. Root 2 is root 8 by pi is to root 3. That indicates this value finally 1 is 1.128 is to 1.224. It means one molecule is there, 1.128 molecules present in C bar, average velocity molecules, and 1.224 number of molecules will be RMS molecules. This is the graphical representation, the same before what I told you. This is T1 temperature, T2 temperature, T3 temperature. So velocity increases, the fraction will increase at a particular maximum point and then decreasing. So this is observe at lower temperature, this you observe at room temperature, this you observe at higher temperature. The same graph I am showing you with molecular velocities with molar mass. See here, M1 is the highest weightful gas. That is the reason the speed is less up to end here itself only. Then M2 is somewhat lighter than this M1. The molar mass of M2 is less, hence the gases will move somewhat fast. M3, the mass is very less. That's the reason the molecule's velocity is high. So see here, when lower mass molecules move fast, this is the lower molecules M3, the molecular mass is less. M1, inside here, whatever the molecules are there, this molecular mass is high. That's the reason it is moved up to here itself only. This is somewhat high, it is moving here. So this is comparative